With A&D Technology's iTestEV, test automation is made simple. Our standard application can easily be modified to your test automation, data acquisition, and control specifications. There are literally no restrictions to the amount of personalized functionality available to the end user. This is the main display from our standard application. As you can see, it's been broken down into sections. The test section, which records simple test information, the battery section, which has our total charge, state of charge, and the battery temperature, and the PPS section for our power processing system that has the set point and the current mode that the power processing system is in. Below that, we have a quick battery overview, which is for individual cells. So we have our maximum cell voltage at this time and our minimum cell voltage at this time, also current available. Now, since the battery is not turned on yet, we don't have any information flowing. And over here we have our main control panel. The auto start function will start all the systems simultaneously. Essentially, it's running the ready, reset, and start processes for you. You could do those individually, and that would be a manual start mode. The stop function will stop all of the units at the same time. Again, since it's customizable, you can make this function work exactly how you want to. Below that, you have your statuses for the test cell status, what mode you're currently in, and whether or not you're logging data. And then below that, you have your limits section and your faults. So if you were to fall out of any limits, or if you were to fault out on any of the modules, that information is available here. And you can click these buttons to get access to more detailed information for each of the events. I'd like to take you through each one of the displays. Keep in mind that every display that you see is completely customizable. The battery coolant conditioner shows that right now we are connected to the driver and our control is set to remote. However, the run status is still stopped. So our set point and feedbacks will not match. As you can see, the feedback temperature of the coolant right now is at 25 degrees C, yet the set point is set for 30 degrees. And we're not ready to turn the system on yet, so we're just going to review these next displays. Power processing system, most often referred to as the cycler, has its own display also. Again, we have our set point and the mode that we are in. And then on this section, it shows the upper and lower limits for each one of the settings and the current set point that is going out. Right now we're in remote mode with the independent configuration. The remote voltage sensing is not turned on, and our CAN communication is okay. Also, we get our station ID and which channel of the cycler that we're connected to. By pressing the manual mode button, I get an additional display. With the manual mode display open, you have control between remote and local modes of the cycler. You also can change the configuration just by clicking one of these buttons. Remote voltage sensing can be turned on or off, and in this case we have sim control. The sim control allows us to run our tests in simulation mode, so we don't actually have to be connected to any of the hardware. This voltage mode control allows us to speed up or slow down how fast the simulated battery charges or discharges. And then also we have the ability to select our modes: voltage, current, power, or standby. The set point can never go below the minimum set point for the battery pack, so at this point it's bottoming out at 1/2 volt above the minimum voltage for this pack. Again, your high and low limits are set down here at the cycler, and we have a button that allows us to use the battery limits by the manufacturer. So once we've input those into the system one time, we can always override any of the ones that are manually typed in simply by clicking that button. We also have control to our driver from here. So manual mode for the cycler allows you to get full access to the cycler as if you were standing at the front panel. Let's move on to our environmental chamber display. Here we have the Cincinnati Sub-Zero environmental chamber module installed. We have access to the driver, and here it's telling us that this is the master PC. We also have a secondary PC. Since two individual tests can run at the same time in one chamber, one of them has to have control of the temperature and humidity. In this case, the master will control. We also have access to turn the light on or off, and we have status lights on top of the chambers. And currently that green light is blinking, telling us that the system is okay, but there is no test running. Of course, we have standard set point and feedback control, and we also have dew point feedback. Below that, we have alarm statuses that will show us detailed information for any alarms that get set. Let's move on to the battery display. Here at the top you see we have control to turn on and off the battery pack. We also can edit our pack information. From here, the battery pack information can be edited. Since this is a simulation, we can choose any amount of cells and the maximum voltage and capacity that we want, and the system will adjust accordingly. The general information is most commonly used, and those fields will be carried on to the test header. From here you can see that we are not connected to the CAN yet, so we do not have any information flowing. We will turn the battery on when we begin our test. Having the picture of the generic battery module is to show you how easy it is to customize a display. Going back to the main display, we will now focus on our test control toolbar. This allows you to select any of the automated tests that are already in the system. Currently this demo has 2 tests installed, the GSCT and a US06 charge sustaining. We're going to try to run the US06 charge sustaining test, simply by clicking on it and hitting the start button. The log header form gives you another chance to change test information before the test begins. After clicking yes, the auto start feature will begin. One of the first things that will happen is we'll try to wake up the battery. You can see by the status messages as we go through the different steps that the battery is waking up. At this point now the battery has been fully awake and the test has started. Now we will move down to the test portion. This is the automated test display, also referred to as our block sequencing. From this view you can watch the test complete step by step. As each step is active, it will blink green in the background. As we return to our main screen, we'll begin our first test. At the test control toolbar, we have access to all of the tests that have been loaded into this solution. Currently we are running 2 different tests, the GSCT and the US06 charge sustaining. We're going to run the US06 charge sustaining for this demo.